This is electricity with a potentiometer. Here are some of the algorithms you will have to use, like resistance times the current equals the voltage, or the current times the voltage equals the power. First of all, what is a potentiometer? A potentiometer is a dial or knob, as shown, used to control voltage by twisting it a certain amount of degrees. It receives power through one pin and transfers it and splits the voltage to the other two pins, depending on the degree in which it is rotated. One can also use only two pins in which it becomes a variable resistor. Okay, so here's the in pin. So in other words, this is where power is going in. So if you were to twist this all the way to the right, this pin all the way on the right would be receiving 5 volts. If it was twisted halfway, they would both these pins would be receiving 2.5. Now in series, when power goes in and this is rotated to the right, this will be receiving 5 volts. If it is rotated halfway, this would be receiving 2.5, just like this pin. Okay, so let's read the question. In two circuits, they both had a potentiometer set to the same value. The potentiometer is rotated at 3/4 to the right of its full rotation span. Both circuits consisted of an LED with the resistance of 1R and a resistor of 3R. The circuit was supplied with a 5-volt battery. Given this certain situation, is the LED more bright with the parallel circuit or the series circuit as shown on the next slide? So these are the two circuits from the previous problem. First of all, as you can see, the power goes into the potentiometer and then comes out of one side into a resistor and then the bulb, and then it goes back to the end of the battery. This one, it's the same thing, but power goes in and then it comes out of both these sides of the potentiometer into the circuit. Now when I showed you these potentiometers, the power is coming out of both of these on the right. It doesn't matter where power goes in, no matter what, it's going to be split within the same way, no matter where the pin's supplying the power or where it's supposed to go to the ground. Okay, so now I understand this solution could seem a bit confusing at first, but hopefully I'll try to explain it. The solution of the parallel is brighter, mostly because of the resistor in the series circuit is placed before the bulb, as shown. See, the resistor is right before it gets in the bulb. In the parallel, it's on the other path relative to the bulb. See, they're on opposite paths. Also, since the dial is turned the same amount of degrees, both of them are receiving the same voltage. So in other words, this is receiving the same voltage as this one going to the bulb because they're in the same location. And if it's turned the same degrees, no matter what, these will be getting the same amount of power. Okay, so if both of these paths are receiving the same amount of voltage, but this one has a greater resistance because there's a bulb and a resistor, and just with the resistor, this is greater than the bulb by itself. Therefore, this one must have less current to equal the voltage because the voltage divided by the resistance equals the current. So if it's the voltage divided by a bigger resistance, you would get a smaller current. If it's divided by a smaller resistance, you would get a larger current. And since power is voltage times the current, this one has a larger current, so multiplied by the same amount of voltage as this one means you would have a greater power. But since this one has a greater resistance, therefore less current, If you multiply that by the same amount of voltage you get from this, you would get less power because there's a greater resistance, therefore there's less current, and current times the power current times the voltage equals the power. Okay, that's it. And